Hi friends, my name is Savannah Soltis, and today I will be expanding your minds about the possibility of life outside of our solar system, mainly focusing on exoplanets, what they are, how we find them, and which ones we have found. And I'm not quite sure how this is going to go, considering that I'm a really great procrastinator, but we'll see, so let's get started. Life outside of our solar system will most likely form in exoplanets, or maybe even the moons of exoplanets. But today we're just going to focus on exoplanets because those are easier to find than something small, orbiting something really far away. And an exoplanet is basically just a planet that is outside of our solar system. And the kind of exoplanets that NASA and other agencies are looking for are the ones that are like our Earth and that are also orbiting a sun-like star, and making sure that that planet is also in the star's habitable zone. And the habitable zone is just a range of distances where the planet isn't too hot and it isn't too cold, where it's just the right temperature that it can sustain water and possibly where life could begin. Astronomers are looking for sun-like stars because they based all of their research off of the solar system's origin story. And that is that there was a spinning cloud of gas and dust, or known as a protosolar nebula, and it eventually collapsed under its own gravity and formed the sun and planets. As the cloud collapsed, the conservation of angular momentum meant that the soon-to-be sun should have spun faster and faster, but that wasn't the case, since the planets contain 96% of the angular momentum and the sun holds 99.8% of the solar system's mass. The young sun would have had a very strong magnetic field, whose lines of force reached out into the disk of swirling gas. And once those field lines connected with the charged particles of gas, it acted like anchors which slowed down the spin of the sun, but it sped up the speed of which the gas spun, and it would create the planets, and eventually created our solar system. Most sun-like stars rotate slowly, so that means that they went through the same magnetic braking that our sun did, and that planet formation must have occurred for them too. So in conclusion, planets must be around sun-like stars. But how do we find exoplanets? Well, during the first discoveries, astronomers relied on the radical velocity technique, or the wobble method, which basically just measures how much a star wobbles. And it is easier to detect if the planet is bigger because that planet will pull on the star, but that star will also pull back on the planet, which causes a shift in the star's position, and that shift will show up on spectrographs as red shifts and blue shifts, and if these shifts are consistent and repeating, it shows astronomers that a planet or a body must be orbiting that star. And another way of finding exoplanets is the transit method, which measures how much a star's light is dimmed when a planet passes in front of it. And this works really well, but it works even better when there are more planets, because the more planets that pass in front of the star means that the light of that star will dim even more. And another way that astronomers find exoplanets is that they just take pictures of a star, but they will remove the glare of the star so that planets that are orbiting will be visible. Along with these methods, there are also several satellites and telescopes in search of exoplanets, and some of them include MOST, which is the microvariability and oscillations of stars, NASA's TESS, which is NASA's Transiting Exoplanets Survey Satellite, and leading in the Doppler wobble search is the HARP spectrograph on the European Southern Observatory's LICIA, which is the 3.6-meter telescope in Chile. And the Kepler spacecraft started the search for exoplanets and found over 3,000 of them, but since then it has ended its mission. When astronomers first started discovering exoplanets, most of them were Jupiter-sized or larger gas giants that orbited close to their parent stars. And the first confirmed discovery in 1992 was of 51 Pegasi b, which is an exoplanet with half the mass of Jupiter, and it orbited really close to its parent star, Helvetios, which was in the constellation of Pegasus. And this planet is most likely tidally locked, just like the way our moon is to our Earth. Another important exoplanet is HD 209458b, which is also orbiting a star in the constellation of Pegasus. It was found in 1999, and it was the first discovered by transiting its star, which once again is just how much the star's light dims when a planet passes in front of it. And it was also the first planet outside of our solar system that astronomers could begin to determine the aspects of its atmosphere. The next exoplanet is 55 Cancri e, which is one of 5 exoplanets orbiting the star 55 Cancri A, which is in the constellation of Cancer. This star is bright enough to see by eye, so that meant that astronomers could study its star and the planets orbiting it in more detail. And 55 Cancri E's orbit is 17 hours and 41 minutes long. And some theorists speculate that it's a carbon-rich planet and it has a diamond core. And the last exoplanet that we're going to be talking about is HD 80606b, which is obviously orbiting the star HD 80606, because where else would they come up with that creative of a name? But anyways, this planet stands out more than the others because of its unique orbit. It has an orbit like that of Halley's Comet, which is an oblong orbit around the Earth, hence why we only see it about every 75 years. But HD 80606b spends about 100 of its days out of its year traveling the oblong route away from its star and then returning to it, but when it returns, it only spends about 20 hours sweeping by the star, using its gravitational pull to swing back into that oblong route. Now, I would love to spend several more hours talking about all the great exoplanets we have discovered, but we don't really have all of that time, so let's just do a quick recap. Alright, first off, exoplanets are just planets, but they're just outside of our solar system. And astronomers are looking for Earth-like planets orbiting Sun-like stars. Second, a habitable zone is just where a planet is at a good distance from a star so that it's not too hot and it's not too cold. Third, there are many ways to find exoplanets, but the 3 that we talked about were the wobble method, which is just measuring how much a star wobbles, the transit method, which measures how much the star's light dims when a planet passes in front of it, and then that astronomers can just take pictures of a star, but they have to dim the star's glare in order to see the planets that are orbiting around it. And as time goes on, astronomers will be discovering more and more exoplanets, and hopefully one of those exoplanets will show some sign of life. And I don't know about you, but I'm pretty excited for that day to happen. But anyways, thanks for watching.